So we've looked at adding, subtracting, multiplying polynomials, and all that stuff basically boils down to distributing, simplifying, combining like terms. Dividing polynomials is where it gets a little bit different because dividing is just a little bit different in general in the math world. So if you have 574 divided by 3 without a calculator, it's not like I'm just doing 574 times 3 or plus 3 or minus 3. I'm going to set it up this way. How many times does 3 go into 574? So 3 goes into 5 one time, and then to come back around, I'm going to do 1 times 3 is 3. Subtract, so 5 minus 3 is 2. Bring down the 7. 3 goes into 27 9 times. Come back around, 9 times 3 is 27. Subtract 27 minus 27 is 0, so that goes away, but then I have to bring down the next term, 4. Ask yourself, how many times does 3 go into 4? One time. When I come back around, remember, notice how I'm like lining everything up here. When I come back around, 1 times 3 is 3, subtract, and I have a 1. Okay, well, if I were going to keep going and have decimals, I could keep going and have decimals, but 3 doesn't go into 1, which means I have a leftover number. I have a remainder of a 1, which means I could write it like this, 191. So 3 goes in 191 times with a remainder of 1. So there's 1/3 left over. The 3 comes from this 3 right here. And that's dividing the long way. So I'm going to do another problem. First, I'm going to shrink this down. And then I'm going to do how many times does 3 go into, and I could do 4 or whatever number I want to do. So let's do that. How many times does 4 go into 1002? 4 doesn't go into 1 at all, so I leave that first blank, just blank. 4 goes into 10, though, 2 times, so I'm lining it up right here. To come back around, 2 times 4 is 8, and you don't have to actually put an X there, just leave it blank. Subtract, 10 minus 8 is 2, and then after I subtract, I bring down the next term. So now I'm asking, now how many times does 4 go into 2, but how many times does 4 go into 20? And that's 5 times. Come back around, 5 times 4 is 20. Subtract, and I get 0, but then I have to bring down the next term, 2, which is also my last term. 4 does not go into 2, so I have 25 and a remainder of 2 over 4, because this same number here is what my remainder is out of. So my answer would be 25, and you don't say 2/4, I'm going to reduce that to 1/2. Now, what we're going to get into in a little bit is using long division, but with polynomials. And what you're going to find here in just a second is if I have 1002, that's a very different number than 12. If I ask you how many times does 4 go into 12, well, 12 divided by 4 is just 3, which is completely different than 25 into half. These zeros were called placeholders, and that comes back in long division. So taking a look at this first problem, I have x cubed, x squared, x, no x, divided by x minus 1. Okay, now if I had this was gone and I just had x cubed and I jumped from x cubed to x, I would need a placeholder right there. That's like saying 102 instead of 12. So I would have to put something right there, but I don't have that in this problem. The first one's set up pretty nice. So I have to find out how many times does x minus 1 go into x cubed plus 5x squared minus 3x minus 1. Now, back up here with long division. I wasn't finding out how many times does 3 go into 57, how many times does 3 go into 574. You looked at it piece by piece. Just like over here, 4 didn't go into 1, but 4 went into 10. And I was just looking at the first part, piece by piece. So when I go to divide here, I'm just going to look at the first part. I'm just going to look at the x and the x cubed, piece by piece, part by part. So how many times does x go into x cubed? Basically, what's x cubed divided by x? And that would be x squared. So x goes into x cubed x squared times just 1 x squared time, because there's a 1 there and a 1 there, which means I'm going to line up that 1x squared above the x squared, because I'm lining things up place by place, piece by piece. Okay, so to come back around, I have to do what I just did before, which is multiply. Trying to erase that. There we go. So I'm going to multiply this by this. And this is where you have to be careful, because it's not x squared times x, it's x squared times x minus 1. So x squared times x is x cubed minus x squared times 1 is x squared. And you could see why if we didn't have that there, we need a placeholder, because I need something to put where the x squared is. And when you go to subtract, you have to be careful. It's just like elimination when we did systems, because that cancels out, but it's 5x squared minus negative x squared, which makes it positive 6x squared. Not 4x squared, 6x squared. And then I'm going to bring down my next term, just like we did above when we had numbers and we brought down the next term and we brought down the next term, just adding parts to it. Now I'm going to go again. How many times does x go into 6x squared? Well, ask yourself, what's 6x squared divided by x? And that's 6x, because 6 divided by 1 is 6, x squared divided by x is x. So 6x needs to go above the x, lining them up. And it's positive, so plus. So x minus 1 goes into 6x squared minus 3x, 6x times, and to come back around, I'm going to multiply that by that. So 6x times x becomes 6x squared minus 6x times 1 is just minus 6x. I'm going to subtract, and that cancels. And I have negative 3x minus negative 6x, which is negative 3x plus 6x, so I get a positive 3x. Because remember, two negatives make a positive. And then I bring down the next term. So now I have to find out how many times does x go into 3x? Well, what's 3x divided by x? That's just 3. Which would line up with the negative 1, no x, those constants are what we call it. Okay, and then to come back around, I'm going to multiply 3 times x minus 1 is not 3x minus 1, it's 3x minus 3. So when you go to subtract, that cancels out, and I have negative 1 minus negative 3, which is 2. And notice that there's nothing else to bring down. Once you've reached your constants, that's it. Now, can x go into 2? No, x can only go into something that has an x. I can't do 2 divided by x. That would just stay 2 divided by x, which means that last part that we brought down, there's our remainder right there. So when I go to write my answer, what's a long polynomial divided by x minus 1? It's this, x squared plus 6x plus 3. But I have to include that remainder. Like up here, I included the 1/3 because it was divided by 3. Over here, I included 2/4 because it was divided by 4, which reduced to 1/2. Here, my remainder is 2, so I'm going to add in that 2, which is my remainder, divided by what I was dividing by, x minus 1. And that's my answer. So dividing polynomials a little bit different. If I were going to multiply this by this and distribute everything out, I would go back to my original function. But most of the time, most people will just check their work instead of going back and multiplying every little thing out. Okay, taking a look at the next one, I have 4x cubed plus 3x squared minus 20x minus 46 divided by x squared minus 5. Hopefully you're noticing something in here. I'm going to give you a chance to think about it. In this problem, you need a placeholder. Basically what it's saying right now is you have 105. And when you go to divide, 105 is not the same thing as 15. So when I go to divide it, I'm putting it into 4x cubed plus 3x squared minus 20x minus 46. But I'm not going to write x squared minus 5 because I need a placeholder. So what's missing? X. So I'm going to include a 0x. Okay, why am I including 0x? Because there are no x's. I just need a placeholder. I need something to be there so that way I don't end up with 15. I needed the 105. That 0 makes the difference. $105 versus $15 or $1,005 versus $15 makes a big difference. So now that I'm going to go divide piece by piece, how many times does x squared go into 4x cubed? So what's 4x cubed divided by x squared? Well, 4 divided by 1 is 4. X cubed divided by x squared is x, which means 4x would line up way over here, and that's okay. You can skip a couple of, sometimes you have blanks right here. So 4x, and now I'm going to multiply and come back around. So 4x times this. 4x times x squared is 4x cubed. The next one doesn't matter because 0 times anything is 0, so I can just put a big old 0. And then 4x times negative 5 is negative 20x. And now I'm going to go subtract. That cancels. 3x squared minus, there was nothing to take away because there wasn't anything there. I'm going to be left with 3x squared. 3x squared. And it's not negative 20x minus 20x. It's negative 20x minus negative. I think I just said that. Sorry, y'all. Anyways, they end up canceling out. And so I have a 0 there. So I'm going to put that placeholder because I have 0 x's now. And I'm going to drag down the next term, negative 46, and go again. So how many times does x squared go into 3x squared? Well, 3x squared divided by x squared is just 3. Which means that 3 needs to line up above the 46. No variable, no variable. I'm going to multiply and come back around. So 3 times x squared plus 0x minus 5 becomes 3x squared. There's nothing there, so 0 minus 15. I'm going to subtract. That cancels. 0 plus 0 makes 0. There's nothing there. And it's not negative 46 minus 15, but negative makes it negative 46 plus 15, which is a negative 31. And there's nothing to bring down. So that's my remainder. So how many times does x squared minus 5 go into this? Well, my answer is it goes in 4x plus 3 times with a remainder of negative 31 over what I was dividing by, x squared minus 5. And I put a minus here because my remainder was negative 31. That's it. So far, none of these have gone in evenly. So sometimes they're not going to go in evenly and you're going to have a remainder and that's okay. But if it does go in evenly, then that means that you can completely take it out. It's a factor. If I ask you what's x plus 5 times x plus 7 times x plus 3 divided by x plus 3, that takes out completely and I'm left with that. So it worked out nice and neat. If it works out nice and neat, that means that it is a factor. So down here it says use polynomial long division, 1i, to divide p of x. That just is representing a polynomial function, p polynomial. So p of x by x squared minus 7. Is x squared minus 7 a factor? How do you know? So when I'm dividing x squared minus 7, I need to be careful that I have a placeholder. So I'm going to find out how many times does x squared minus 7 go into 3x cubed minus 8x squared. Everything's lining up so far. Minus 21x plus 56. And I'm going to warn you right now, write super, super small, because if you've noticed, long division problems are they take up a lot of vertical space, not so much horizontal space, but we don't really have that in this problem. So here we go. X squared goes into 3x cubed, x times, but 3 divided by 1 is 3, so it goes in 3x times, so I'm all the way over here now. Come back around. 3x times x squared minus 7 is going to give me 3x cubed, and I forgot my placeholder, so there's nothing right here, because 3x times 0x is just 0. 3x times 7 makes that positive 21x. Remember, I did piece by piece, and then I multiplied to come back around. Now I'm going to subtract. That goes away. Negative 8x squared, take away nothing. I'm still left with negative 8x squared. And then negative 21x plus negative 21x becomes... This was a -7. My bad. If you look at the timestamp, I can't talk anymore. Oh, it's too late. Okay, come back around, and this should have been 3x times -7. At least I didn't do 8 divided by 2 is 2 this time. So 3x times -7 becomes negative 21x. There we go. So back to this. So negative 21x minus negative 21x, because that double negative, now it does cancel out, and I'm left with a 0. Bring down the 56. So to recap, because it's kind of my mistake, I needed a placeholder here because I jumped from x squared to the constant. I forgot the x in the middle. So I put in a 0x right here. How many times does x squared go into x cubed? 3x times. Multiply to come back around. Subtract, and this canceled. This canceled. So I put a placeholder, and now I'm here. Now find out how many times does x squared go into negative 8x squared, and that would be negative 8 times. To multiply, I'm going to come back around. So negative 8 times x squared plus 0x minus 7. Negative 8 times x squared is negative 8x squared. There's a 0 because of the placeholder. And negative 8 times negative 7 is 56. So notice it's matching up here. So when you go to subtract, matches up. Everything cancels out. There's nothing else to bring down, which means there is no remainder. It goes in 3x minus 8 times. So is x squared minus 7 a factor? Yes. How do I know? Because there's no remainder. If it goes in evenly and there's no remainder, then that means that it's a factor. So if it goes in evenly, there's no remainder, that means that it's a factor. Now, I want you to try this next one on your own. See what you get. If you get a remainder, that means it does not go in evenly. If you do not get a remainder, it does go in evenly. And don't realize you're going to need a placeholder here. So do this before you start the next video. Try this one on your own, and then you can check it in the next video. See you in a bit.